Now that we've learned how to calculate the 6 trigonometric ratios for quadrantal angles, we can focus on the 6 trigonometric ratios evaluated at multiples of 45 degrees. In section 1.4.3, we're going to use a 45, 45, 90 triangle to do that very thing. Now, a 45, 45, 90 triangle has 2 angles equal to 45 degrees and 1 right angle. You probably remember from geometry that opposing sides of equal angles are equal. So if we set the horizontal segment of our 45, 45, 90 triangle to be 1 unit long, then the vertical segment is also 1 unit long. Remembering that Pythagorean theorem is a squared plus b squared equals hypotenuse squared, we could solve for the hypotenuse and we would see that the length would be square root of 2. So when we have a 45, 45, 90 triangle, the sides will always be in this proportion. Recall that to evaluate the 6 trigonometric ratios at a specific angle, we need a point on the terminal side of that angle. A convenient point to use, as you'll see, at least here in quadrant 1, is the point 1, 1. Let's try to use this special triangle to evaluate the following trig ratios. We'll begin with cosine of 45 degrees. Now, the diagram that we have above will be sufficient for evaluating cosine of 45 degrees. Recall that cosine is x over r. So the x coordinate is 1. I can see it right here in my ordered pair. And the distance r is square root of 2. So cosine of 45 degrees is x divided by r, or 1 divided by the square root of 2. Remember, it's customary to rationalize the denominator in trigonometry, so we end up with the square root of 2 over 2. So cosine of 45 degrees is equal to square root of 2 over 2. Now, it may be the case that we're going to have to reposition our special triangle to fit other angles, like example B, sine of 3 pi over 4. Now, 3 pi over 4 is an angle in quadrant 2. So I'm going to, first of all, construct this angle, 3 pi over 4. And then we're going to fit a 45-45 degree angle, 45-45, 90 triangle in that space. A point on the terminal side of 3 pi over 4 could be -1, +1. Remember, what I have right here is a 45-45, 90 triangle. So the horizontal segment would be measured at -1, the vertical segment would be +1, and the hypotenuse would be square root of 2. So the ordered pair of a point on the terminal side of 3 pi over 4 would be -1, 1. Remember, you can use any point on the terminal side of an angle. We're using one that's very convenient. Now, to find sine of 3 pi over 4, we need to evaluate the y-coordinate divided by r. The y-coordinate in this case is +1, and r is square root of 2. So if we rationalize the denominator by multiplying the top and the bottom by square root of 2, we figure out sine of 3 pi over 4 is square root of 2 over 2. Let's try that same technique on the next example. This time, we're going to evaluate tangent of -135 degrees. Notice -135 is a multiple of 45 degrees. Its terminal side is over here in quadrant 3. So here is the angle -135 degrees. Now we can fit a 45-45, 90 triangle in this spot right here. Here we have an angle of 45 degrees, which means this angle is also 45 degrees. So if we set the horizontal segment to be -1, then the vertical segment would also be -1. So we have ordered pair -1, -1 on the terminal side of -135 degrees. Notice the signs, SIGNs, for x and y are simply determined by the quadrant in which we're working. Since the terminal side of -135 degrees is in quadrant 3, x is negative and y is negative. Now, the ratio that we're working with here is tangent. Tangent is calculated as y divided by x. -1 divided by -1 is +1. Remember, all students take calculus. All students take calculus. The sine of tangent in quadrant 3 is positive, and that's what we came up with in our calculations. Let's try one more example. Secant of 225 degrees. 225 degrees has its terminal side again in quadrant 3. So constructing 225 degrees, we can construct the same 45, 45, 90 triangle that we did on example C and fit it in this spot right here. So once again, we'll use the point -1, -1 on the terminal side of -225 degrees. Remembering that secant is r divided by x. R, of course, is this hypotenuse length, square root of 2. R is square root of 2. X is -1. Therefore, secant of 225 degrees is negative square root of 2. So if you're working with an angle in your trigonometric function that's a multiple of 45 degrees or a multiple of pi over 4 radians, then you can use a 45, 45, 90 triangle to conveniently determine a point on the terminal side of that angle and then evaluate your trigonometric ratio.